Attention manufacturers, if you manufacture any steel or iron components, either you will have the phosphating process in-house or you will be outsourcing it. In any case, this video will help you achieve better efficiency and improve your phosphating process. So stay tuned. Phosphating is a chemical process for treating the steel surface. In phosphating, a thin layer of metal phosphate is formed on the surface of the steel. Usually the layers that are formed are either iron phosphate, zinc phosphate, or manganese phosphate. Phosphating is a pre-treatment process done before any surface coating or painting operation. Depending on the type of metal phosphate used, we can get some added benefits as well. Like manganese phosphate has the ability to retain oil. So it provides anti-friction and even anti-wear and anti-corrosive properties to the surface. Zinc phosphate is used where anti-corrosion properties are more important. As I said earlier, phosphating is a chemical process. So the surface or the metal to be coated is dipped inside a bath containing phosphating solution. Now this solution reacts with the surface of the metal and an unwanted byproduct is created out of this chemical reaction. This byproduct is called phosphating sludge. This phosphatic sludge is normally in the form of a white powder. If ignored, the phosphating sludge keeps on accumulating in the phosphating bath. Now this creates three main problems. One, it drastically reduces the efficiency of your phosphating process. Number two, generally phosphating is done at elevated temperatures. That is, the phosphating bath has heaters in it. So when there is sludge in this bath, unnecessarily the heaters work extra to heat this impurity. So you waste electricity and consume, and it has value, it has cost. Number three, if there is no sludge separator, removing the sludge is a manual process. Now imagine a closed tank where this white powder or white muck is getting generated and accumulated over time. If this tank is not cleaned with a set frequency, the sludge inside the tank reaches such levels that I've seen or I've heard stories from customers that half of the tank is almost filled with sludge. Now, depending on your production volumes, this sludge generation is going to increase. So, if there is no sludge separator, imagine you will have to stop the process. You'll have to drain out the entire phosphating bath. Somebody has to go inside the tank and then clean the tank from inside manually. It is not only time consuming, it is dangerous for the person cleaning the tank, and third, you waste the phosphating bath in this changing. So how does innovation solve this problem? Let me take you to the system. This is the setup for our phosphate sludge separation. We are going to install this system very soon at one of the leading auto component manufacturer in Pune. So let me explain what this system is. This is a 2-inch actuated ball valve which will be connected to the drain of the phosphate tank. Now the phosphate solution will flow through this by gravity. Once the level inside the tank increases, through by the sensors attached on this level sensor, this pump will start. Now this pump that we have selected is a tank mounted semi-open impeller centrifugal pump. From this pump, the dirty fluid will be pumped inside the centrifuge. Inside the centrifuge there is a rotating assembly which is directly mounted on the motor. Now when the motor starts, the entire assembly rotates. Inside the rotor is a rubber pot. The dirty fluid coming from the tank will be pumped inside the rubber pot, and because of the centrifugal force generated by the motor, the sludge or the phosphate sludge, the phosphate powder, will be thrown out and will stick to the rubber pot, and clarified fluid will come out and will flow back to the phosphate bath. Now let me explain why we have done a setup like this, why we think this is how the phosphate solution separation setup should be. Now, as I explained earlier, the phosphate sludge settles at the bottom of the phosphate tank. It is very difficult to remove the sludge from time to time manually. So it is clear that we need some system which will remove the sludge from the bottom. So that is the reason why we connect the drain of the phosphate tank to this tank. Now why we need a separate tank? Why can't we connect the pump directly to the phosphate tank? The reason is no pump in the world, almost no pump in the world or no inexpensive pump in the world can handle the phosphate sludge that will be accumulated inside the tank. Since the pump will be mounted outside the tank, there is a very high chance that the mechanical seal inside the pump will get damaged because of the sludge. If that happens, the pump will start leaking and the entire shop floor will be covered in the phosphate sludge and the phosphate solution. We don't want that to happen. So we thought it was better to have a separate tank where we will collect all the sludge. Second advantage of this is that the sludge won't be settled inside that tank, in the main process tank. The sludge will flow, all the sludge will flow to the intermediate tank, and if it settles, it will settle over here in this tank. And again, because the pump is a tank mounted pump, semi-open impeller, even if it fails, the fluid is going to be drained or it is going to leak inside the tank. Nothing is going to come out. So this is the reason why we have selected a setup like this. Now, why we use a centrifuge? So centrifuge is a non-consumable type of separation system or a filtration system. By non-consumable, I mean there is no filter media which gets consumed over time. Inside there is a rubber pot which can hold up to 4.5 kgs of sludge. Once that is filled, what we do is we stop the motor and we remove the rubber pot, and we give a spare pot which can be placed inside the rotor, and the system can be started again, while the other rubber pot can be cleaned and kept ready for the next cycle. So apart from the fact that this is a non-consumable system, centrifuge also offers, it is also compact, it is not much, the size is not much. The quantity of sludge that it can handle is, like I said, it is 4.5 kgs. Depending on the production volume, for this particular application, they will have to clean the rubber pot or replace the rubber pot maybe once in 2 days, which is okay by them. And centrifuge also, so the quality of phosphating solution coming out of the centrifuge is also close to 15 to 20 microns, which is quite acceptable. The simple reason for this kind of setup is that separation of phosphate sludge is required. Filtration is not required. You don't need 1 micron filtered fluid for phosphating. The main purpose of this kind of a separator is that the manual labor involved in cleaning the phosphate tank should be avoided. And this setup does that perfectly. If you found this video to be useful, please subscribe to our channel, Think Filter. Also, if you have any questions, please comment below. Thank you.